Hello viewers, welcome to my channel. I'm Hasham. So now I'm going to start the problems on analysis of variance, ANOVA. Last video I have explained the complete theory regarding what is analysis of variance. It's a statistical technique where we compare more than two samples. When only two samples are to be compared, t-test we apply. When we have more than two samples, we have to apply the statistical technique called analysis of variance. It is widely used for experimental design. In research area, this analysis of variance is widely used when we compare the means of more than two samples. So this is the application of analysis of variance. In analysis of variance, two types of problems are there, one-way ANOVA and two-way ANOVA. If we consider only one factor, we apply one-way analysis of variance, one-way classification. If we consider two factors at a time, two-way ANOVA. So we have to read the problem, see the problem, what it is asking, then we have to apply one-way or two-way ANOVA. So you have to remember the table. The one-way ANOVA table and two-way ANOVA table that I have explained completely in the last video. So if you have not watched the theory video, I suggest you to go to the playlist of my channel. Select the subject statistics for management. Select the video of analysis of variance theory. Be acquainted what is there in analysis of variance. Then you watch the problems. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. So always keep ready the problem, then watch the video. Take a screenshot of the solution of the very first problem, then I'll explain all the points. Come on, this is the first problem on analysis of variance. See the problem carefully. Set up ANOVA table for the following per hectare yield for three varieties of wheat grown on 4 plots. So there are three varieties of wheat, that is A1, A2, A3. Every variety of wheat is grown on 4 plots, plot 1, 2, 3, 4. And the per hectare yield in 100 kilograms are given. Example, A1 variety of wheat. First plot 600 kilogram, second plot 700, third 3, then 8. These are the output from 4 plots by applying A1 variety of wheat. When we apply A2 variety of wheat, the output are 5537. These are the output on 4 plots by applying A2 variety of wheat. When A3 variety of wheat is applied, the output from the 4 plots are 5434. So simply we have to set up ANOVA table. In the next problem onwards, we have hypothesis testing. All testing steps we have to apply. This is the first problem where it is not asking you to test the hypothesis. It is simply asking you to make up an ANOVA table. Only one way, because we are considering only variety of wheat. We are not considering the plots. We want to find out only variety of wheat, differences in variety of wheat. That's all. So this is the first problem on ANOVA. See carefully how to proceed. Calculations for ANOVA. So we are concerned only with the columns. In columns we have variety of wheat. So how many varieties? A1, A2, A3. 3 variety. So for each variety of wheat, 2 columns I am making. So for A1 variety, X1 and X1 square, 2 columns are required. Then for A2 variety of wheat, 2 columns, X2 and X2 square. For A3 variety of wheat, X3 and X3 square. Now X1 are nothing but the values given in the problem. And X2 values are given, X3 values are given. The output from A1 variety are 6738 given in the problem. So 6738 are the output from A1 variety. Take the total of summation x1 24. Now square it. 6 square 36 because x1 square. So 6 6 are 36, 7 7 are 49, 3 3 9, 8 8 is 64. Take the total 158. So two columns we have made for A1 variety. Now two columns for A2 variety, x2 and x2 square. x2 values are the output from A2 variety given in the problem. In the problem it is given the output from A2 variety 5537. The total summation x2 20. Square it. 5 5s are 25, 5 5s are 25, 3 3s are 9, 7 7 49. Total 108. Similarly for A3 variety, two columns x3 and x3 square. Now take the values given in the problem 5 4 3 4. Take the total 16. Square 5 5s are 25, 4 4 16, 3 3s are 9, 4 4 is 16. That's it. Complete table we have prepared. We got all the totals. Now we'll find out the different values. The first step, sum of all sample items. It is denoted as T. Sum of all sample items. It is denoted as capital T. The first step. So T is equal to summation x1 plus summation x2 plus summation x3. Here summation x1 is there 24. Summation x2 20. Summation x3 16. So 24 plus 20 plus 16. 24, 20, 16. T is equal to 60. What is T? Sum of all items in all the samples. First step. Second step, correction factor. It is denoted as CF. CF is equal to T whole square by N. How much T we got? 60. So 60 whole square divided by N. N stands for number of items in all the samples. Always keep a notebook beside you. When I say something, immediately note it down. N stands for number of items in all the samples. In first sample, how many items are there? 1, 2, 3, 4. 4 items are there in first sample. Second sample, 1, 2, 3, 4. 4 items. Third sample, 1, 2, 3, 4. So 4 items are there in each sample. So first sample 4, second sample 4, third sample 4. So 4 3 is 12. So totally 12 items we have. So N is equal to 12. Now 60 whole square divided by 12, you will get 300. What is this 300? CF, correction factor. 2 steps we have completed. Third step, the total sum of square of all the items. The total sum of squares of all the items, it is denoted by SST. Sum of squares of all the items. Total of all the items. T stands for total. Sum of squares of total. Now SST is equal to summation x1 square plus summation x2 square plus summation x3 square minus correction factor. Now here you are having x1 square 158, x2 square 108, x3 square 66. So add up 158 plus 108 plus 66 minus correction factor. Correction factor we got 300. So 158 plus 108 plus 66 minus 332. What is this 32? SST. In the coming every problem we have to follow these steps. Whatever we are doing right now, this is the first problem, so give more concentration. SST over. Now sum of squares between columns. Here total sum of squares SST. Here sum of squares between columns SSC. Sum of squares between columns. The formula SSC is equal to summation x1 whole square by n1 plus summation x2 whole square by n2 plus summation x3 whole square by n3 minus CF, because 3 samples we have. Summation x1. How much is summation x1? 24. So 24 whole square. Don't think that it is summation x1 square. This is not. This is summation x1 square. This is summation x1 whole square. So summation x1 is 24. So 24 square divided by n1. n1 means number of items in the first sample. In the first sample A1, how many items are there? 1, 2, 3, 4. 4 items. So N1 is equal to 4. So 24 into 24 divided by 4, you will get 144. plus summation x2 whole square by n2. Summation x2 is how much? 20. So 20 whole square divided by n2. How many items are there in the second sample? 4. 1, 2, 3, 4. n2 is equal to 20 whole square divided by 4. You will get 100. Plus 16 x3. Summation x3 whole square. 16. 16 whole square divided by 4. So 16 into 16 divided by 4. n3 is 4. How many items are there? 1, 2, 3, 4. Every sample consists of 4 items. So n1 4, n2 4, n3 4. It may be different. In the coming problem, it may be different. Minus CF, correction factor 300. So 144 plus 100 plus 64 minus 300, 8. SSC, sum of squares between columns, 8. So we got SST, we got SSC. Now sum of squares within samples, that is called error. Sum of squares within samples, error, SSE. Simply SSE is equal to SST minus SSC. From total deduct columns, SST minus SSC. What you get? SSE. So SST is 32. 32 minus 8. You will get 24. So SSE 24. That's all. These are the calculations we require for ANOVA table. Now this is the ANOVA table. One way ANOVA table. 5 columns are there. Already I explained you in detail in the first video. So that's why I'm stressing you. If you want the complete command, watch the first theory video. Then it will become easier. The 5 columns are there in ANOVA table. First, source of variation. Second, sum of squares. Third, degree of freedom. Fourth, mean squares. And last, fifth, variance ratio. Every problem, the table remains same. Values will change, but the table columns will remain same. First one, between samples, columns. Between, in a variation between columns, samples. SSC, sum of squares between columns, because it is columns. So how much is SSC you have calculated here? 8. Degree of freedom, C minus 1. C stands for columns. How many columns do we have? 3 columns, 3 samples. A1, A2, A3. 3 samples. So C is equal to 3. 3 minus 1 is 2. MSC, mean squares of columns. Mean squares of columns. That is equal to SSC divided by degree of freedom. SSC divided by degree of freedom. SSC is how much? 8. 8 divided by 2. 4. That's all. Second, within samples, error. That is called SSE. How much we got SSE here? 24. So SSE is 24. Now degree of freedom is N minus C. N stands for total number of items in all the samples. Here we have taken N is equal to how much? 12. 4 items first sample, 4 items second sample, 4 items third sample. Total 12. So here N is 12. C, columns is 3. 12 minus 3 is 9. Now MSE. MSE is equal to SSE divided by degree of freedom. So 24 divided by 9 will get 2.67. So we got MSC, we got MSE. Now F ratio. F ratio is equal to MSC divided by MSE. So MSC is 4, MSE is 2.67. You will get 1.5. So F ratio is 1.5. This is the computed value of F. In this first problem, only it is asking you to make the table. So I have prepared the table. I am not testing the hypothesis. In the next problem, it will ask for testing hypothesis. Then we'll apply all the steps. Null hypothesis. Then next one is level of significance, degree of freedom, test statistic, critical region, decision. That we'll do it in the next video. Next problem. First problem, only it is asking you to make the ANOVA table. Come on. Now I am going to start the second problem on ANOVA. Previous problem, first problem, simply we have prepared the ANOVA table. We have not applied the steps of hypothesis testing. But in the second problem, we have to complete problem we have to do. We have to prepare the ANOVA table and also we have to apply all the hypothesis testing steps. See the problem carefully. three fertilizers A, B and C are grown. So three samples are there. C is equal to 3. So A, B, C are grown to different number of plots of uniform area and their yield in kilograms are as given below. So three fertilizers are applied on different plots of the same area and we have measured how much yield we got from the different fertilizers. Test whether the average yield of the three fertilizers is same at level of significance of 5%. So level of significance given in the problem 5%. So we have to test whether average yield from the three types of fertilizer is same or not. See here, in the problem it will not specify that it is an ANOVA table. So whenever we compare three or more than three samples, we apply ANOVA. If only two samples are there, we have to apply t-test. Here fertilizer A, the yield from fertilizer A are 7, 11, 9. That means A fertilizer is applied only on three plots. And first plot we have given, we got an yield of 7, second plot 11, third plot 9. These three are the output from A fertilizer. B fertilizer was applied on 5 plots of equal area. So the output from B fertilizer are 4, 6, 8, 5, 2. The C fertilizers are applied on 4 plots and the output are 10, 8, 6, 8. That's all. So here ABC fertilizers are given in rows. We convert it into columns. Again, it's a one-way ANOVA because we want to find out the variation only among fertilizer, only between fertilizer. That's it. So before explaining the solution, take a screenshot of the solution of second problem, then I'll completely explain each and every point. So this is the first complete problem on hypothesis testing of ANOVA. Now first of all, calculations for ANOVA. Fertilizers. Three fertilizers are there, A, B, C. We have divided each fertilizer into two columns, x1, x1 square, x2, x2 square, x3, x3 square. So how many values are given for A fertilizer? 3 values. That is 7, 11, 9. The total is 27. Come to x1 square. 7 sevens are 49. 11 into 11, 121. 9 nines are 81. Take the total 251. We have squared the values. B fertilizer, the values are given 4, 6, 8, 5, 2. Given in the problem. The total comes to 25. Square it. 4 4s are 16. 6 6 36. 8 8 is 64. 5 5 25. 2 2s are 4. Total is 145. Same rule for C fertilizer. The values given are 10, 8, 6, 8. Total 32. 10 square 100, 8 square 64, 6 square 36, 8 square 64. Total 264. We got all the totals. Now we start calculating. The first of all we have to calculate the sum of items in all samples. Sum of items of all the samples. So what is the sum of the first sample? 27. Second sample 25. Third sample 32. So T stands for total of all the items of all the samples. So summation x1 plus summation x2 plus summation x3. 27 plus 25 plus 32. It comes to 84. T is equal to 84. First step. Second step, correction factor CF. T whole square divided by n. So 84 whole square divided by n. N is 12. N means number of items in all the samples. First sample we have 3 items. Second sample we have 5 items. So 5 plus 3, 8. And third sample we have 4 items. 8 plus 4, 12. So N is equal to 12. So 84 into 84 divided by 12, 588. 588 is the correction factor. Now we calculate SST. Total sum of squares of all the items. total sum of squares of all the items. It is known as SST. The formula is summation x1 square plus summation x2 square plus summation x3 square minus CF, minus correction factor. So x1 square how much? 251 plus 145 plus 264 minus 588. So SST we got 72. Next is sum of squares between samples or columns. Sum of squares between samples or columns, SSC. The formula is summation x1 whole square by n1 plus summation x2 whole square by n2 plus summation x3 whole square by n3 minus CF, correction factor. So x1 is how much? 27. Square 27 whole square divided by n1. n1 stands for number of items in the first sample. In the first sample we have only 3 items. So n1 is equal to 3. Then x2 whole square, x2 is 25. So 25 whole square divided by 5 because 5 items are there. 1, 2, 3, 4, 5. n2 is equal to 5. Then x3 is 32. 32 whole square divided by 4. 4 items are there. n3 is equal to 4. Minus CF. CF is 588. So 21 whole square divided by 3 you will get 243. 25 whole square divided by 5 125. 32 whole square divided by 4 256 minus 5. So SSC we got 36. Now sum of squares within samples, it is called error, SSE. So SSE is equal to SST minus SSC. No formula is there. Simply you subtract columns from total. So SST is 72. SSC is 36. So 72 minus 36, 36. Over. All the calculations are over. Now, ANOVA table. 5 columns are there in ANOVA table. First column, source of variation. Second, sum of squares, net degree of freedom, mean squares, F ratio. Same thing what we have done in the first problem. The column remains same. Now, between samples or columns. Between samples or columns, SSC. How much is the SSC here? 36. So before making this table, we have to make all calculations. SSC 36. Degree of freedom C minus 1. How many columns? 3 columns. A, B, C. So 3 minus 1, 2. MSC is equal to SSC by degree of freedom. 36 by 2, 18. Now come to within samples or error. SSE. How much SSE we got? 36. And degree of freedom is N minus C. N is 12. Already I told you. Number of items in all the samples, 12. So 12 minus 3 is 9. Now MSE is equal to SSE divided by degree of freedom. So 36 divided by 9, 4. Now SST is 72. Already we have calculated here SST 72. And degree of freedom is N minus 1. 12 minus 1 is 11. Now you can confirm 2 plus 9 is equal to 11. 36 plus 36 is equal to 72. Now F ratio is MSC by MSE. MSC 18, MSE 4. 18 by 4, 4.5. Computed value of F, we got 4.5. So up to table we have prepared. Now we have to apply the hypothesis testing steps. The first step, laying down of hypothesis, null and alternative. Null hypothesis. The meaning of null is no difference. There is no difference in the average yield from A fertilizer, B fertilizer, C fertilizer. Any fertilizer you apply, the average yield will remain same. That is null. Mu1 is equal to mu2 is equal to mu3. The average yield from 3 fertilizers are same. Now alternative hypothesis, opposite. When we say null, it is same. Alternative, it is different. The average yield from the 3 fertilizers are significantly different. Mu1 not equal to mu2, not equal to mu3. Now, level of significance alpha 0.05 given in the problem, 5% level. Now, degree of freedom. Here, 2 degree of freedom we have to take. one degree of freedom for numerator and the other degree of freedom for denominator. Here F ratio, numerator is MSC. For MSC, what is the degree of freedom here? 2. And for denominator MSE. For MSE, what is the degree of freedom? Degree of freedom is 4. No, we have committed a mistake here. No, it's correct. Degree of freedom is n minus c, 9. N minus c is 9. So here degree of freedom 2, here degree of freedom is 9. So here V1 is equal to degree of freedom for numerator, it is 2. And here degree of freedom for denominator it is 9, not 4. Denominator degree of freedom is 9. Now critical region, the table value. Now you have to refer the table. This table, F table, I will provide the PDF in the description. Take a printout of the PDF of this F distribution table and keep it ready. Now here in this table, first of all, two tables are there, one 5%, one 1%. So normally only two level of significance are there, 5% and 1%. That's why two tables are provided. On the top you can see 1% points. Here top you can see 5% points. So 5% and 1%. Now it is the level of significance is 5%. So see the table, 5%. In this 5%, in the columns it is given degree of freedom for numerator in columns. In rows it is given degree of freedom for denominator, right? So we have 2 degree of freedom, 1 degree of freedom for numerator, the other degree of freedom for denominator. So degree of freedom for numerator is 2. So in the columns you can see 2. And degree of freedom for denominator in rows you see 9. So 9 and 2 is 4.26. So here you can see under 2 against 9. Under 2 against 9. You can see 4.26. So 4.26 is the table. The table value of F at 5% level for V1 is equal to 2, V2 is equal to 9 is 4.26. It is 4.26. Again I repeat, this is the F distribution table, 5 degree, 5%, and degree of freedom for numerator is given the top. So 2 degree of freedom for numerator and 9 degree of freedom for denominator. So against 9 it is 4.26. So 4.26. The critical region lies for F greater than equal to 4.26. So 4.26 or higher. So here in this diagram, this is 4.26. So 4.26 or more will lie in rejection region, and below 4.26 will lie in acceptance region. Now we have to find out our computed value. Our computed value is 4.5. Our computed value is 4.5. Here any value more than 4.26 will fall in rejection region. So our value 4.5 will lie in rejection region here. 4.5. It is falling in the rejection region. When it falls in rejection region, the null hypothesis is rejected. This null hypothesis we reject, and alternative hypothesis we accept. So null hypothesis it is saying the average yield is same, that is rejected. Alternative, the average yield is significantly different, this will accept. So here the computed value of F 4.5 is more than the critical value 4.26. 4.26. So it falls in rejection region. So it falls in rejection region. The null hypothesis is rejected. And we conclude there is significant difference in the average yield from the 3 type of fertilizers. Actually earlier I have committed a mistake here. I have taken 4. That's why I got a different value. The correct degree of freedom is 9, not 4. This 4 is the MSC. So 9 is the degree of freedom. So degree of freedom for denominator 9. So numerator 2, denominator 9. So refer the table, you get 4.26. So any value which is more than 4.26 will fall in rejection region. So our computed value is 4.5. 4.5 is greater than 4.26. So it falls in rejection region. The computed value 4.5 is more than critical value 4.26. So it falls in rejection region. Null hypothesis rejected, and we conclude there is significant difference in the average yield from the 3 types of fertilizers. That's all. So in this video, I have completed 2 problems on how to make the ANOVA. First problem, only I have prepared the ANOVA table because it is asking you only to make the table. Second problem, it is asking you to apply the hypothesis steps. So all the steps I have applied. Steps are similar. Only the computed value of f we have to calculate by making all these calculations. That's it. Inshallah, the next problem will continue in the next video.